finally, we want to look at an irrational function and see if we can't piece all the pieces we have together to get one big graph. Now, what do we actually have to look at? We need to look at the zeros, the long-term behavior to the right, the long-run behavior to the left, and what's going on near any vertical asymptotes. I'll try to tabulate some stuff over here. Let's see here. I want the zeros first. Define zeros, we set the top equal to 0, like that. And we're going to get x equals -1 and x equals 3. X equals -1 and 3, like that. Can we see that? Quite. All right. Now remember, what that tells us is that -1 zeros on the graph. And 3 zeros on the graph. Like that. Now, let's do the long run behavior to the right. Let's see here, as we look further and further to the right on the graph. Remember, what we're supposed to do is look at the largest term on the top, the largest term on the bottom. If I multiply out the top, the largest term would be x squared. If I multiply out the bottom, the largest term would be x squared. So I'm going to put a little squiggle here, meaning approximate. And so what that says is that way to the right, the y value should be very close to 1. That tells us there's a horizontal asymptote at that height. How much different is it if we say, look further and further to the left? Well, I'm supposed to look at the dominant term on top. If I multiply the top, I'm going to get x squared just like before. If I multiply the bottom, the biggest term is going to be x squared like before. Yes, I'm going to put a little squiggle here for approximate equal to, like that. And that says, way to the right and way to the left, the height of the y values is very nearly 1. So the horizontal asymptote on both sides, let's see here, horizontal asymptote on both sides, I'll have to worry about that at the end, of y equals 1. Y equals 1, here we go. All right, just tabulating our little information here. The next thing we want is to see what's going on near the vertical asymptotes. Well, we find vertical asymptotes by setting the bottom equal to 0 and making sure it never cancels with anything on the top, and it doesn't, right? So we can see that the only the only vertical asymptote that happens is at x equals -4. What we want to do is see what the graph actually looks like, because you can do lots of weird things near an asymptote. So I'm just going to draw this like this so I can move something over perhaps. Now, near x equals -4, let's just this is going to be our little scratch pad here. Near x equals -4, what happens? Well, let's see. -4 plus 1 is about -3. So let me put a little squiggle here. It's about -3. X minus 3, that -4, that's going to be -7. And on the bottom is that x plus 4 squared that's going nuts. That's the thing that actually causes the asymptote. Now that's going to be a positive constant. Times, well, I like times better. Times, yeah. Times 1 over x plus 4 squared. Now what does 1 over x plus 4 squared look like? It looks like the power function, which we know, 1 over x squared. Well, 1 over x squared looks like this. We studied that before. I always think that looks like a volcano. You can use that description if you like. You don't have to. But what happens here in our situation is it looks just like this, except shifted 4 to the left. So what I'm going to do is go like this, and just go like this, and go like this. That's the only part of the graph I'm actually putting in yet. And once I know I have this and this, I'm going to erase everything that's not this and this, and I'm going to try to put all of these other things back in and see if we can't get a graph. I'm going to go like that. I don't want this thing here. I don't want this thing here. I don't want any of this stuff here. Right, so technically the only part of the graph I have graphed at the moment, yes. Let's see here what I have here. I want 1, 2, 3. All right, all right, it'll work. Now, I'm going to start putting in the other stuff. I know I'm supposed to have a 0 at -1. that dot is definitely on the graph. I know that 3 is definitely on the graph, so I can put that in there like that. If I really wanted the y-intercept, we can find it, but I'm hoping I don't actually have to do that. What do I know? I know that way to the left and way to the right, the height is supposed to get 1. So what I'm going to do is draw that asymptote like this. Right? And I know way to the right and way to the left, the graph is supposed to get close to that. So way to the left, this is no problem. Yes, it's definitely going to do that. Now, what happens in the meantime? This part of the graph has to go through this dot and this dot. All right? I'm going to try to draw something that goes through that dot and that dot. And then way to the right, I'm supposed to get close to this orange asymptote again. So it's going to go off like that. And we've pieced together the whole graph. I think if you actually put this into your graphing calculator or Desmos, you'll see something a lot like that. You will need this skill in physics and calculus. They really, places where the graph blows up and long-term behavior, both are really important. And we have to have a way of understanding how to piece it together. And that's it.